Hi, physical science students. Welcome to your second week of trimester 2. This week we're going to be learning all about distance and displacement. If you haven't already checked out the Cornell note-taking template for this week, it is right here. So pause the video and copy this onto page 3 of your INB. So remember, we're starting over for trimester 3, so we're renumbering in our notebook, starting with page 1 that says trimester 3, page 2, and then these notes will go on page 3. All right, so our essential question for these notes are, what is the difference between distance and displacement, and how do we calculate them? So distance is the total length of how far something has gone. The units for distance are things that you recognize like miles, but also metric units, and these are the abbreviations for some metric units here, like the millimeter, the centimeter, the meter, and the kilometer. Distance is a scalar measurement. So scalar is one of those vocabulary terms that you defined last week. It means that it's a measurement that doesn't have a direction. It's just a length. Displacement is somewhat similar to distance, except for it is the shortest distance between a starting and an ending point, and it has a direction. The units for displacement include the units that you saw before, but they also have a direction attached to them. So you might hear something like miles south, or centimeters northwest, or meters east, or kilometers southeast. Displacement is what we call a vector measurement because it's a measurement that includes a direction. So this picture really describes well the difference between distance and displacement. So if you're going on a bike ride and you're riding on the paths through a park, your path could look really windy, so there's lots of different routes you could take. You could go through here and follow this red line. You could go around the circle a couple of times and then go this way, maybe go out here. And by the time you got to the end of this path over here, your distance is going to be much longer than your actual displacement, because your displacement is simply the distance from your starting point to your ending point. All right, so we have some steps to solving distance and displacement problems, the type of problems that we're going to be solving in class. All right, so the first step is to draw a picture. And so you're usually going to get a word problem, and you're going to turn that word problem into a picture. So you want to start by labeling your starting point on your graph paper. And that graph paper will either be real paper or more than likely virtual paper. Draw each segment as an arrow. That'll make sense when you see an example. And it has to be to scale, right? So when we say to scale, we might mean 1 square equals 1 meter, something like that. And then finally, after you've drawn all the segments, label your endpoint. Next, you have to calculate the distance. And for calculating distance, it's just a matter of adding up the numbers for each segment. And lastly, we want to calculate displacement. And this can take a little bit more work. So we have to first draw an arrow from the starting point to the ending point. If our arrow is vertical, so remember vertical means up or down, like this. Or if our displacement arrow is horizontal, so like this, then all we have to do is count the boxes on our graph to get our answer. But if it's diagonal, so if our arrow goes off at a diagonal, then we have to use the Pythagorean theorem, right, where this actually winds up being our C, and we'll show you how to count up your A's and your B's so that you can calculate your answer. All right, we're going to look at 2 example problems for these notes, and we're going to do lots more examples throughout the week. All right, so here's a summary of the rules that you just copied into your notebook. Right, and we're going to solve this problem right here. Miss Jones drives to school each day, but on her way has to drop off her son. So here is her route. All right, so here I'm marking my starting location because the first step is to draw a picture of this problem, right? And it says to label your starting point. So this is going to be my starting point, and I'm just going to put an S. You don't have to write the whole word start. Then we're going to draw each segment to scale. So what does that mean? It means that each one of these lines here on my graph paper represents 1 mile. All right, and then once I've drawn all my segments, I'm going to label my ending point as well. All right, so the first segment is 6 miles south. So that's going to be an arrow that goes 6 blocks down. The next one is 7 miles west. So that's going to be over 7 to the left. 10 miles north, which is going to be up 10. And then 7 miles east. East is to the right. So it's going to be 7 to the right. All right, and now I need to label my ending spot. So I have all 4 of these. So now this is going to be my ending spot, so I'll just label it with E. The last thing to do is to calculate the distance and calculate the displacement. So for the distance, if we're calculating the distance, all you have to do is add up the numbers. Right, so we had 6, 7, 10, and 7. 6 plus 7 plus 10 plus 7. And so that gives us a total of 30. And now we can't just leave it a number. This is a measurement, so we also have to have a unit, right, with a unit. And so the unit that's on this problem is miles. All right, and so that's our distance. All right, number 3 says to calculate the displacement. And this answer will have both a unit and a direction. All right, so the first step is to draw a straight line from our starting point, which is right here, to our ending point, which is right here. So that'll look like this. All right, if it's a vertical or horizontal line, then we can count the boxes. Well, we're lucky here because this is a vertical line. It goes straight up. So all we have to do is count our boxes. All right, so we have 1, 2, 3, 4. And so it looks like our displacement right? That's what this red arrow represents. Our displacement is simply going to be 4. And now we need the unit, right? Our unit is going to be miles. But we also need a direction. So what direction is our arrow pointing when it goes from start to end? It's pointing north. So we're going to add that onto our answer. 4 miles north. Or you could just leave it with a capital N. All right, so now we have all the parts. We drew our picture, we calculated the distance, and we calculated the displacement. Let's look at another example problem. All right, this time we have a student who maybe they're doing lots of different things in school. They're walking 2 kilometers north, then 4 kilometers east, 4 kilometers south, and then 6 kilometers west. So here we have a starting location right here. So I'm going to call this my S for start. And the next is 4 kilometers east, which would look like this. So we went 4 places to the right. Then 4 kilometers south and 6 kilometers west. All right, and that's all of the directions. So this right here is going to be our ending place. All right, so we have our picture drawn. The next step is to calculate our distance. All right, so calculating distance is the easy part. It's just going to be the numbers. So 2 plus 4 plus 4 plus 6. So that's going to be 16. And we still need units. We can't just leave a number. The units that we're using in this problem were kilometers. Okay, so here's our answer, 16 kilometers. All right, for the second part, calculating displacement, for this one, the first step is to draw our arrow from our start to our end. So this arrow represents our displacement. To find the length of the displacement, it's going to be a little trickier this time. So this time we're going to have to use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so our displacement is actually the c squared part. All right, this is side C. And over here, if you look at the displacement, it actually kind of makes a triangle, doesn't it? Right, so if you turn this whole thing into a triangle, then this would be A, and this would be B. These would be the other sides of your triangle. So we're going to count these parts. All right, so it looks like A has 2 squares, and it looks like B also has 2 squares. All right, and that's going to let us find our displacement. So here we're going to say 2 squared plus 2 squared equals c squared. So this is our displacement. All right, and so 2 squared is 4 plus 4 equals c squared. All right, so 4 plus 4 is 8. So we know our displacement squared is 8. Well, how do we get rid of that square? Right now, we don't have displacement until we get rid of it. We do that by taking the square root. Okay, so really our displacement is going to be the square root of 8. All right, but we're not done. That's just the number. Remember, when we do displacement, we need the unit. So the unit will be kilometer. And we also need direction. So we have to think about it this time. If we're pointing off down here at an angle, right, and our compass says north, south, west, and east, right? And so our displacement's kind of pointing this way, then we have to say southwest for our direction. All right, and that's it. Those are our 2 examples. We're going to do lots more of these over the course of the week. Okay, so let's just wrap this up real quick by comparing the distance and displacement. So distance had the total length of travel, but displacement was the distance only from the start to the end. Both of them used units of length, but displacement also includes direction. Distance we calculate just by adding, but displacement we have to calculate by counting or using the Pythagorean theorem, a squared plus b squared equals c squared. All right, that is it for this week. Look forward to seeing you guys in class and doing some practice.